I'm glad to share something on the linear and polynomial regressions and some basic knowledge behind them, and also some knowledge on how to make a complete data mining circles. So we will go along with the code I have put on the GitHub, and those code have been edited and modified yesterday, and I will upload the newest version after this lecture. And initially, we should note what we should do when we want to just apply machine learning, because before applying the algorithms, there are several steps we need to do. So the first thing for R to do is the data collection, and it's the work done by the crawler. And going to talk something like that. So we'll focus on uh, the rest four steps, the data exploration. And here on the left side, here is the code I have written on the Jupyter notebook. And after this lecture, you can download them from the GitHub. And also you can have this template of this document. And I will just try my best to tell what the what the codes are used for and how they work. The first block you can see here is some setup I have written. It's just some setup, and every time when you wanna run when you start a new project with the machine learning, you can put the code in the first block in the top of your Jupyter notebook. And like this functions the save fig, which means that every time when you just plot a figure through the pandas, and you can just cite this function, and it would help you to save the figures on your current working directory. And even if you don't make any directory named images, and it will create automatically. So no worry about it. And this, like the matplotlib, are kind of parameters set for the better depictions of the picture. So the normal way for us to do is to know how to just start to read an Excel from the directory. So it's the essential skills you need to learn. You should know something about the scikit-learn, scikit-learn package, and also you should know what it refers to, NumPy and pandas, because it is related to the structure of the data. And if you have no idea on these two packages, and you will get a lot of troubles, because when you are actually doing coding by yourself. And all of these packages are achieved by Python. So even if you know the just the even if you know the circles of how to just apply or how to do data mining, but the essential skills are needed for them. So in the first part, we are going to see what data exploration means. Like I have just or three aspects we usually do when we are in data exploration. Firstly, we will just check what the data are. Like this, we can use the data head. And as you can see, is the abbreviation PD. PD is the abbreviation of the pandas, and NumPy and MP means NumPy. PD means pandas. So our read Excel is just a master of the pandas. And I can just use the abbreviation of pandas, PD dots read results. And also, after it is read, it will be in the form of the data frame. Data frame. Because pandas has two normal data structure. One of them is data frame and the other is series. So all the data will be read into a data frame, and it's quite easy to understand because it's just like a sheet. Okay. So we should run the code, and all the code are executable, which means that you can run it just by replacing the data set you want to try. And you should put this data set in the Sany directory as the code it is, where the code it is. We can use the head method to see the top 5 data samples we have in this data sheet. And we can see that there are numerous null values in the sheet. And this is what we need to fill the missing value, and we can talk later. And we can use the columns method to see the name of the columns in this sheet. And then we should create a duplicate, because sometimes when we are just doing some operation on the data sheet, and it will change the original one. So in case that the original one will be changed, so we should make a new copy. And here you can see the ILOC method. It just an index to locate where or which column you want to copy it, or which column in that sheet you want to fetch, and you want to just do some action on it. And you can check the documentation of those methods if you want to have just DIY do it yourself round, and you should check the detail of how every method work. Because we know scikit-learn is a package, and NumPy is a package, and Panda is a package. So inside the packages, there are a bunch of methods you should know how to just operate. And then we can use the info method to get specified on what there is. Like you can see, you can check every column whether there so how many samples each column has, and how many are null value the data samples is. And this is just straightforward for you to get some, just to have some idea on this data sheet. And it would help you to establish a straight feeling on that. And you can use the describe, and it can do some basic statistical method like the mean value of each column, and the standard deviation and the minimum value. And you can divide them into 4 parts, because you can check which value represents for the 20% of this value in this column, like the SiO2. And after just doing some methods, to get the basic insight, and you can visualize them in the graph like this. And you can use the histogram. Is the method also. You can just use it. And you can see that all the column, and we can call features, are be shown in each graph. And you can see because the verticals means the verticals or like the vertical coordinate means the quantity of this element or not element or state, and the horizontal coordinates representing for the content, which means representing for the percentage or maybe the value of this art state. And just through this job, you can note what the sheet is like. And this is something about the distribution in data exploration. And also what we can do is to find the correlation among them. So how can we do? We can just use also all of the function has been packaged already in Python. So if you are good at Python, you are good at data mining through Python, and you will know how to use those kind of method for you, and they are suitable for the specific circumstance. Like when you wanna check the person correlation coefficient among them or between each pair of attributes, and you can just use this method, and it will show you each pair of attributes or each pair of the features, and you can find the correlation coefficient here. And also we can choose specific column to see the correlation between between it and others. And every method has some attributes you can set like the thing, and it's not needed for you to remember all of them. When you want to just apply them, you can just check their documentation. And it's quite easy to do by this way. Like or this is one way to just to start this is just way start to check their things, just their internal function inside internal function of Python. Like when I and then if I don't know what method the numpy has, and what I can do is just like numpy and correction, and it will tell you something about that, and you can check some methods it has, this package it has, or some others package it has, and all of them will be just be listed here. And also if you think that is not enough, because this is the just formal documentation the Python organization put on the website, and you can check other usages other people are making when they are in their own project. So it's quite easy to do like this. Okay, it's using it. No. And then we can use the scatter matrix to check the correlation as we have. And also why we see why I talked before that the safe figure has been made, like the safe fig, and it can help you to start this image on your own computer. Because when I run it, like the data sheet has been put in the same directory as the linear polynomial regression IPython's document. And when function, it will create a file it will create a directory called images, and all the images will be just stored automatically when you run this function in this document to Python notebook like this. When it start to work, it will tell you you are saving the figure call for successfully, like the call for, and you can change the name of it. And every time when you want to know what the function or how the function works or what the function is for, you can check some notation behind every Python function like this. Because I have put some notation on how it works and what every attribute or what every parameter it refers to. Okay, like the fig ID means picture name. So you can name the picture by yourself. After the data explanations or the distribution, and the most important thing, and is fight and also is vital, especially for the data mining, means which means feature engineering, because sometimes when you are dealing with some columns of some specific dioxide, but dioxide, but that's oxide or dioxide, it's not enough, because maybe you should do some combination of them. Like you can use the first column over the second column to create a new one, and you can subtract them, or you can just multiply them to create a new column and append the column into the original data sheet to make a new features. And why it's so important? Because we know for machine learning, it just learned the relationship between the physical world and the math or mathematical world, and how does it do that? Because it just find the relationship uh, from the real world, where it reflects some specific attribute into the parameter space. And the job for the machine learning to do is seeking to find the relationship between those reflex. And it's quite important to construct the parameter space, especially the dimensionality of the parameter space. And each column here, which means each um, oxides here, which dioxide here, or which oxide here, will just be part of the parameter space, and it will be one of the dimensions in this space. So it's quite important to do the feature engineering. But how can you do that? You should have some base size on the data itself. After you just make some exploration, and you can try with some new features, which is called feature engineering. Okay, moving on. So now we can see that there are tremendous now value inside the data sheet. So the first thing for us to do for the data processing is to just dealing with the missing value. And almost the missing value we need to do in this project or in this science group is to just it's just kind of the numeric value, which means that you can do some interpolation. And I think that maybe you guys have learned something or learned some methods to deal with that, or when you have the meeting with the statistical group. And so there are some basic here in Python also. Like you can use the is now and this way to check which column has the now value. And then the FUNER function like this. The first parameter is the value you want to fill with. And you can change it with whatever value you want. and all the missing value will be filled with the or with the specific value you designate. And also, when we are doing with the numeric value, we should pay attention to its scaling problem. And when we are doing, because the scales, the magnitude of every features will actually just influence or affect hugely on the performance of the machine learning algorithms. So, or we will talk something like that later. And when we are doing the data processing, there are there are two types of data we are going to deal with. The first type is the numeric value, and especially it will be shown in this project as the missing value. And the second one is the non-numeric value, like the categorical variable. And also there are some common ways to do that, like the job or label encoding or one-hot encoding. And we are not talk or this method in this lecture. And if you are interested, and we can just have some discussions later or after this lecture, and that's fine. Or so until now we have know the data exploration and the data processing, and now it's the time for us to go deeper into the machine learning algorithms we want to apply. And we will focus on the specific algorithm which belongs to the supervised learning. And this is the work today we are going to concentrate on, the linear regression and the polynomial regression.